one example of a polar graph. Example 2 of what a polar graph looks like. Polar coordinates are a graphing method that represent where a point exists in a two-dimensional space. We're used to graphing in a one-dimensional space, or what is referred to as rectangular coordinates. For example, if you have an x-axis here and a y-axis here, and you want to graph a point 3, 2, for example, you would go 3, 2. That's rectangular coordinates. You would count your x and your y. Rectangular coordinates are expressed as x, comma, y. Polar coordinates are necessary to represent a point in a two-dimensional space, as if you're viewing from an aerial view or from above. For example, if this were the globe, and you're standing right there in the middle, or the North Pole, and you want to plot these points in a two-dimensional space, it's like you're looking down from above. This is why you need polar coordinates. R is the radius, which is from here to here, and theta is the angle, which is the distance from x to the radius. To plot any point, you have to have a point of origin. The center of the circle is your origin, and it is expressed as 0, 0. For rectangular coordinates to polar coordinates, you have to know the relationship between x and y to r and theta. X squared plus y squared equals r squared. This is the equation for a circle centered at the point of origin. There. We know tangent of theta equals y over x. This is our angle, or our radius. Now we know that the x value, or cosine, which also means cosine theta equals x over r. From there, we know that the y value, or sine, or sin theta equals y over r. Now we will graph in polar coordinates the location of 5 over pi over 4. In a circle, we know that there are 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4, counterclockwise. X is 0, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees completes the circle of the polar graph. Earlier on, we learned pi over 4 is equal to 1/4 of 180. That means that 180 degrees, 1/4 of 180 degrees is equal to 45 degrees. From 0 to 90 degrees is half of 180. So this would be pi over 2. 0 degrees to 180 degrees would be pi. So pi over 4 is equal to 1/4 0 to 180. That would be halfway between 0 and 90 degrees. So you'd put it right here. Since that's 5, you count 1, 2, 3, 4, 5, and then that would be your point. There is more than one way to polygraph using your calculator. Today I will show you how to polygraph on the TI-84 Plus calculator. First, you want to turn on your calculator, then clear it and reset it. So second, mem, go to 7, choose 1 for all RAM, then 2 to reset it completely. Now your calculator is cleared. From there, go to clear, then go to y equals. Now you will see everything's cleared, and you'll see the y equals. This will change to r after we change a few things. Now second, on, then turn the calculator back on, and then clear it again. So now you go to the mode key, and then using the arrow pad, go all the way to pol, which also means polar, then you hit enter. You want pol to be highlighted. Now you will press the y equals key. Notice the y's changed to r's. From there we will enter in the equation, the polar equation of the form r equals f parentheses theta. This is one of the equations we will use and be entering. So 1.5 minus 2.5 times, and then cosine, which is cos right there, of theta. Theta is this key with the x plus a circle and a slash and an n. The circle and the slash through it is actually the symbol theta, and then parentheses. You will now hit the graph button, which is in the upper right corner of the calculator. That is one symbol, but to get a better look at it, you will want to press zoom, which is this key right here, and then go to number 4 for ZD decimal. Now you see it on a bigger scale, we're zoomed in. If you use the arrow key, you can see the points and go back and forth on the x and y axis. But that's not what you want to view. You want to see it on points. So you go to second and table. These are the points. Notice how instead of x and y form it is theta and radius. Now if it was in the x and y form, this would be y and radius would be x, so you would switch those around, and then that is how you would graph these points based on degrees. Now I will show you how to convert xy form into degrees so you can know what theta equals when you need to convert an xy coordinate into theta to polar graph. First you will hit mode, and you're using the arrow pad. You want to go to degree and make sure degree is highlighted or changed if it is not already. From there you will hit second and then angle, which is the apps key right here. Next you will hit 6, and it prompts you to put a coordinate from an xy for what you need converted into angle. Notice the theta sign. We'll use the coordinate 3, 3, then you put parentheses. From there you will hit enter, and it gives you 45. It's saying that theta equals 45 for that angle. It's the answer. The angle between the polar axis counterclockwise to rectangular coordinate is 45 degrees. That is what you'll plot